Have you ever wondered why our universe has a speed limit? Why nothing travels faster than the speed of light? This isn't just some arbitrary cosmic rule, it is deeply tied to the fabric of reality itself. Grab your cosmic compass because today we're diving into one of science's most mind-bending mysteries, the speed of light and its role in shaping the universe as we know it. First, let's start with the basics. What exactly is the speed of light? Short answer, it's fast. Light travels at an astonishing 299,192 kilometers per second, or about 186,282 miles per second. If you could travel at the speed of light, you'd circle the Earth 7.5 times in just 1 second. This isn't just impressive, it's fundamental to how our universe operates. But why? So here's where things get a little crazy. According to Albert Einstein's theory of relativity, the speed of light isn't just a property of light itself. It's woven into the structure of space-time. You've probably heard these terms before, space and time. But here's the kicker. They're not separate entities. They're part of the same four-dimensional fabric known as space-time. And the speed of light forms the ultimate cosmic speed limit within this fabric. Einstein's equations tell us that as you move through space faster and faster, time starts to slow down. If you were able to reach the speed of light, time would essentially stop for you. Weird, isn't it? Now hold on. Why does time slow down? To answer that, let's use an analogy. Think of space-time as a giant pool table. When objects move, they create ripples and curves on this table. Traveling faster means interacting with space-time in increasingly extreme ways. At light speed, you're essentially bending space-time to its limits. This phenomenon is linked to what physicists call time dilation. You might have seen it in science fiction like Interstellar, but it's not just fiction. Experiments with atomic clocks have proven it to be real. Astronauts aboard the International Space Station actually age just a tiny bit slower than people on Earth, because they're moving very fast relative to us. All right, so the speed of light plays tricks with time. But why can't anything go faster than light? This has to do with energy. To accelerate an object, you need energy. The faster you want to go, the more energy you need. And as you approach the speed of light, the amount of energy required becomes infinite. That's why no physical object, no particle, no spaceship, not even the Millennium Falcon can reach, let alone surpass, the speed of light. But here's a tantalizing question for you. What if we could break that limit? Imagine humanity discovering a way to travel faster than light. Could we reach distant galaxies in an instant? Meet aliens? Colonize other worlds? Don't get your hopes up just yet. Breaking the cosmic speed limit would shatter all the laws of physics as we understand them today. Causality, the principle that cause comes before effect, would no longer hold true. Events could occur before their causes. Imagine eating dinner before you decide what to cook. Sounds paradoxical, right? That's how fundamental the speed of light is. Still, scientists have pondered ways to potentially circumvent this limit without outright breaking it. One idea? Warp drives. Remember Star Trek? Their warp technology actually has some theoretical basis. By bending and contracting space-time itself, a warp drive wouldn't technically travel faster than light. Instead, it would move the space around it. This concept was proposed in the 1990s by Mexican physicist Miguel Alcubierre. Though it still requires enormous amounts of energy we don't have, it offers an intriguing loophole. Another puzzling area is quantum entanglement. Picture two particles that seem to communicate instantaneously, regardless of distance. Einstein called this spooky action at a distance. Does this mean information can travel faster than light? Not really. While entangled particles have connections that defy intuition, they don't violate the speed limit because no usable information is transmitted faster than light. It's a fascinating mystery nonetheless. So why does this universal limit matter? Let's take a moment to marvel at the implications. The speed of light affects everything in our universe. how light from distant stars billions of light years away reaches us, how GPS satellites keep your phone's location accurate, and even how we experience time and reality. It's the glue that holds our understanding of physics together. Without it, our universe, as we know it, would fall apart. But let's drift into another mind-bending thought: the beginning of the universe itself. The Big Bang, the moment everything originated, seems to defy this very rule. In the initial moments of creation, the universe expanded exponentially faster than light. But this wasn't a case of objects moving through space. It was space itself expanding, carrying galaxies and stars along for the ride. This fascinating phenomenon known as cosmic inflation creates one of the few scenarios where faster-than-light motion is possible, although it's space that's doing the moving, not objects within it. And speaking of paradoxes, could there be exceptions to this rule? What about mysterious particles called tachyons? Tachyons are hypothetical particles that are said to always move faster than light. They remain purely theoretical, and their existence would turn physics upside down, but certain equations suggest they could exist. Just imagine what their discovery might mean for our understanding of the universe. Despite tantalizing possibilities, here's the truth. The speed of light as a fundamental limit preserves our universe's consistency and logic. It ensures that the laws of physics apply everywhere. If this limit didn't exist, things we take for granted, like cause and effect, the nature of time, and the very structure of our universe, might simply fall apart. So what does it all mean for us? For now, the speed of light remains a cosmic constant. It reminds us that even in our technologically advanced world, there are still mysteries that humble human understanding. It challenges scientists, dreamers, and thinkers to push the boundaries of what's possible, all while being a beautiful metaphor for the limits and wonders of our universe. Who knew that something as simple as light, something we experience every day, could hold the key to unlocking the secrets of the cosmos? And so, the next time you look at the stars, remember, the light you see left its source thousands, millions, or even billions of years ago. It's the ultimate time traveler, obeying the cosmic speed limit as it weaves the story of our universe. That's it for today's dive into the mysteries of the cosmos. If you enjoyed this episode and want to see more mind-blowing topics, make sure you hit that like button, subscribe, and share it with your fellow space enthusiasts. Until next time, keep looking up, because the universe has a lot more secrets to reveal.